Hello friends, myself is Anjana Pawar from sgm College Karat. In last lecture, we studied derivative of logarithmic differentiation. So now today is the point of derivative of implicit function. So before we start the derivative of implicit function, we check what is the implicit function. So few example we can write here and then explain the which type of function is implicit function. Okay, so my first example is x square plus y plus minus 3 is equal to 0, and my next example is x plus sin xy plus y is equal to 0. Okay, now this is a one from f of x is given, so I convert y term in entirely x term. So how to convert this y as it is? This x square goes that side is minus, this 3 here minus goes that side is plus, so 3 minus x square means हमने यहाँ पे y term in term of x पे लिखा है. अलग से हम लोग x term in term of y पे भी लिख सकते हैं. कैसे? So this x square as it is रखेंगे, this 3 goes that side is plus, this y goes that side is minus, so therefore x is equal to plus minus square root of 3 minus y. Means अब तक हमने जो फंक्शन देखे थे तो y is equal to होल एग्जाम्पल इन टर्म ऑफ x वेरिएबल. मीन्स यहाँ पे हम लोग मेंशन कर सकते हैं कौन सा वेरिएबल डिपेंडेंट है और कौन सा वेरिएबल इंडिपेंडेंट है. सो यहाँ पे y इज डिपेंडेंट वेरिएबल एंड x इज द इंडिपेंडेंट वेरिएबल. जितना भी चेंज हम लोग x में करेंगे उतना चेंज y में होगा. सिमिलरली सेम एग्जांपल आई विल कन्वर्ट इनटू x इन टर्म ऑफ y. मीन्स यहाँ पे जो भी चेंज हम लोग y में करेंगे वो चेंज x में होगा. मीन्स x इस एग्जांपल में x इज डिपेंडेंट वेरिएबल एंड y इज इंडिपेंडेंट वेरिएबल. सो जो एग्जांपल में वन इज डिपेंडेंट वेरिएबल एंड अदर इज इंडिपेंडेंट वेरिएबल में एक्सप्रेस होता है. फॉर एग्जांपल ओनली y इज इक्वल टू एफ ऑफ x या x इज इक्वल टू एफ ऑफ y. इस टर्म में मीन्स वन वेरिएबल entirely expressed in x variable या x variable entirely expressed in y variable. Those type of function is called as a splitive function. Splitive function means जो फंक्शन एक वेरिएबल में ही गिवन होता है, मीन्स y इज इक्वल टू ओनली एफ ऑफ x या x इज इक्वल टू ओनली एफ ऑफ y. दिस टाइप ऑफ फंक्शन इज अ स्प्लिटिव फंक्शन. सो नाउ दिस एग्जांपल हमें क्या करना है, डिपेंडेंट वेरिएबल को सेपरेट करना है. सो मेरा डिपेंडेंट वेरिएबल कौन सा है, y. सो मैं ट्राई करती हूँ. सपोज y मैंने यहाँ पे लिखा. ओके, अदर सम गोज दैट साइड, सो माइनस एक्स माइनस साइन एक्स वाई. बट यहाँ पे दिस एक्स वाई वी कैनॉट बी सेपरेट बिकॉज दिस इज द एंगल. सो हम लोग सेपरेट नहीं कर सकते. मीन्स एक वेरिएबल को दूसरे वेरिएबल में एक्सप्रेस नहीं कर सकते. उसको विच टाइप ऑफ फंक्शन कर सकते हैं, स्प्लिटिव टाइप फंक्शन. मीन्स दोज फंक्शन इन टर्म ऑफ x एज वेल एज y. x एज वेल एज y में एक्सप्रेस होता है. दोज टाइप ऑफ फंक्शन इज इम्प्लिसिट फंक्शन एंड ओनली वन वेरिएबल में एक्सप्रेस होता है. दोज टाइप ऑफ फंक्शन इज स्प्लिटिव फंक्शन. I hope you understand which type of function is implicit and which type of function is splitive. Okay, so earlier example हमने पहले वाले सब example किए, उसमें y in term of x में हुआ था. Means कंपल्सरी डिपेंडेंट वेरिएबल वन साइड था और इंडिपेंडेंट वेरिएबल अलग साइड में था. लेकिन अब हम लोग जो डेरिवेटिव निकालने वाले इम्प्लिसिट फंक्शन का, उसमें x एंड y फंक्शन टुगेदर में होगा या x एंड y वेरिएबल टुगेदर में होगा और उनका हमें डेरिवेटिव निकालना है. उसमें कुछ भी अलग थिंग्स नहीं है. जो हम लोग डेरिवेटिव के फॉर्मूले यूज़ करते हैं वही फॉर्मूले हमें यूज़ करने हैं. लेकिन यहाँ पे कंपल्सरी y इज अ डिपेंडेंट वेरिएबल होगा और x इज अ इंडिपेंडेंट वेरिएबल होगा. So let's start some examples for derivative of implicit function. So write down my examples. Differentiate the following with respect to x. So my first example, we get example is square root of x plus square root of 1 is equal to square root of a. It is a very easy example. So how to differentiate? This is the example in the expressed as a x and y term. So how to differentiate? Same, differentiate with respect to x. यहाँ पे x is a independent variable है, y is a dependent variable है. So x का डेरिवेटिव स्क्वायर रूट ऑफ x का स्टैंडर्ड हिसाब से डेरिवेटिव क्या होगा 1/2 रूट x एंड अगेन x का डेरिवेटिव विथ रिस्पेक्ट टू x इज 1. सो इसका डेरिवेटिव स्टैंडर्ड फॉर्म से स्क्वायर रूट ऑफ 1/2 रूट x प्लस root of y. Again this is a compare with root of x. So what is the derivative of root of y? 1/2 root y. But y is a dependent variable. So again a derivative of dy by dx is equal to the root of a, which is a constant term. So the constant term derivative is 0. Now your aim is dy by dx is one side and all others term is other side. So this here plus goes that side is minus. So therefore 1/2 root y dy by dx is equal to minus 1/2 root x. Now this here divided goes that side is multiplied. So dy by dx is equal to minus 2 root 1 divided by 2 root x. Now these are cancelled out. So your final answer look like is dy by dx is equal to minus root of y divided by root of x. We can consider single root. So root of y upon x. This is the answer for given examples. Now my next example is x plus x1 plus y. X plus root xy plus y is equal to 1. ओके हमें क्या करना है? सपोज विच टाइप ऑफ दिस एग्जाम्पल इम्प्लिसिट टाइप ऑफ फंक्शन. सो इम्प्लिसिट टाइप में हमें स्ट्रेट फॉरवर्ड डिफरेंशिएट करना है. सो डिफरेंशिएट विथ रिस्पेक्ट टू x. डिफरेंशिएट विथ रिस्पेक्ट टू x. सो x का डेरिवेटिव क्या होगा 1 रूट ऑफ xy विच इज अ कंपोजिट फंक्शन. सो वी कैन टेक अ कंपोजिट फंक्शन थ्योरम. What is the derivative of root of x, which is 1/2 root x, and again क्या कंपोज हुआ है xy. This is the product form. So again we can derivative of xy by using a u multiply product rule. U multiply v product rule. So plus 1/2 root xy is as in derivative, and again a derivative of xy with respect to x plus derivative of y with respect to x, which is dy by dx is equal to derivative of 1, which is a constant, so it is a 0. Now we use here product rule. So this one as it is plus 1/2 root xy is as it is inside the bracket. U derivative of v plus v derivative of u. So x derivative of v dy by dx plus y derivative of x with respect to x, which is 1 plus dy by dx. Now your aim is collect the dy by dx term. So this term goes inside, means multiply inside. So 1 as it is plus x divided by 2 root xy dy by dx plus y divided by 2 root xy plus dy by dx. Now collect the dy by dx term and other term goes that side. So we get here x divided by 2 root xy plus y divided by 2 root xy inside the bracket dy by dx is equal to these two terms go यहाँ पे 1 होगा because dy by dx बाहर निकलने के बाद यहाँ पे 1 रिमेनिंग. Now those term both that side is minus. So minus inside the bracket 1 plus y upon 2 root xy. Now simplify. Here denominator is not same. Both that side is multiply. So we get here x plus 2 root xy divided by 2 root xy multiply dy by dx. Same thing here. Denominator is not same. Multiply here. So we get here minus inside the bracket 2 root xy plus y divided by 2 root xy. Now LHS and RHS denominator are same. So it's cancel out. Now this term here multiply. I want only dy by dx in LHS side. So this term here multiply goes that side is divide. So we get here dy by dx is equal to minus inside the bracket 2 root xy plus y divided by x plus 2 root xy. This is your final answer. But if you want, then simplify again. How to simplify? Minus 2. This root xy we can separate out. So root x multiply root y plus this y we can write root y multiply root y divided by same thing here. This x we can write down root x multiply root x plus this root xy we can separate out 2 root x multiply root y. Now in this term root y is common, take it outside. So minus root y is common inside the bracket 2 root x plus root y. Similarly divided by in this term root x is common, so take it outside. Inside the bracket 2 root y plus root x. So this is your final answer. I hope so you understand. This is a question in MCQ. That time this is your final answer. But this is a question in theoretical. So we can stop here also. Okay. Now we can check next example. Now my next example. Third example. X square multiply y square minus tan inverse of root x square plus y square is equal to cot inverse of multiply cot inverse of root x square plus y square. Okay. Cot inverse of x square plus y square. Now suppose we solve this example directly, so it is very difficult because tan इनवर्स डेरिवेटिव फर्स्ट हमें निकालना पड़ेगा, फिर रूट एक्स का डेरिवेटिव निकालना पड़ेगा, फिर एक्स स्क्वायर प्लस वाई स्क्वायर का डेरिवेटिव निकालना पड़ेगा. सो दैट्स बेटर हम लोग चेक करते हैं. यहाँ पे tan इनवर्स है, यहाँ पे cot इनवर्स है. व्हाट अबाउट एंगल? बोथ एंगल आर सेम. सो दिस tan इनवर्स बोथ दैट साइड इज प्लस. सो वी गेट हियर एक्स स्क्वायर वाई स्क्वायर इज इक्वल टू tan इनवर्स ऑफ रूट एक्स स्क्वायर प्लस वाई स्क्वायर प्लस cot inverse of root x square plus y square. So we have a standard formula, tan inverse of x plus tan inverse of y tan inverse of x plus cot inverse of x. The angle we can write the formula is pi by 2. We have already done. So here we check the angle. So this is tan inverse of root x square plus y square plus cot inverse of root x square plus y square. We directly write down the here pi by 2. So since we have formula tan inverse of x plus cot inverse of x which is pi by 2, which is identity formula for inverse function. Now it is very easy to differentiate. Now differentiate with respect to x. So here u into v rule. So x square as it is derivative of y square by using a x raised to n form formula which is 2y and y is dependent with respect to x. So dy by dx plus y square is constant, derivative of x square, which is 2x, is equal to pi by 2 is constant. Now your aim is dy by dx one side. So this goes that side. So we get here 2y x square dy by dx is equal to minus 2x y square. So therefore dy by dx is equal to minus 2x y square divided by 2y x square. Now again simplify. 2 cancel, 1y cancel, 1x cancel. So we get final answer is minus y upon x. So this type of question, if you use identity formula, sum inverse function, so we use here and now differentiate. Now next example, fourth example. My fourth example, x e raised to y plus y e raised to x. Again this is a implicit type of function. So directly differentiate with respect to x. Here this two term is u multiply v. This also two term is u multiply v. So we can use here product rule of differentiation. So x derivative of e raised to y, which is e raised to y, and again a derivative of y with respect to x, plus e raised to y is as it is, derivative of x is 1, so e raised to y here, plus here we can use here product rule, y as it is, e raised to x derivative is e raised to x, so y multiply e raised to x. Now e raised to x is as it is, derivative of y with respect to x, which is dy by dx is equal to 0 because one derivative is 0. Now your aim is dy by dx together. So these two terms together. So we get here x e raised to y plus e raised to x dy by dx outside the bracket is equal to others two terms goes RHS side. So minus inside the bracket e raised to y plus y e raised to x. Now these are here multiply goes that side is divide. So we get dy by dx is equal to minus inside the bracket e raised to y plus y e raised to x divided by e raised to x plus x e raised to y. So this is your final answer of this example. Now next example, fifth example. E raised to x minus y is equal to x upon y. Okay? E raised to x minus y is equal to x upon y. Again this is a implicit type of function. But this is also one more thing is present. This LHS side is function raised to function. So whenever your example is contain function raised to function, we compulsory use logarithmic derivative. So what is means logarithmic derivative? Your first step is taking log on both sides. So your first step taking log on both sides. Okay. Now you take log on both sides. So we get here log of e raised to x minus y is equal to log of x upon y. Now both sides we use a logarithmic laws. Here we can use a exponential law and we can use here quotient law. Means whatever is power taking front. So we get here e raised to x minus y multiply log of e is equal to log x minus log y. We can use a log a upon b. We can write log a minus log b. Now next. Now log e, which is 1. So we get here e raised to x minus y is equal to log of x minus log of y. Correct? Now it is a differentiate with respect to x, which is a simply form. We get a simply form. Now is differentiate with respect to x. This is a composite form, e raised to x minus y. So first of all, we can take a derivative e raised to x. What is the derivative of e raised to x? Which is e raised to x. But here x is replaced by x minus y. So first e raised to x minus y का derivative क्या होगा? E raised to x minus y. और again a derivative of x minus y. Okay? So therefore e raised to x minus y derivative as it is. Now derivative of x minus y, which is a composite form function. So again a derivative of x minus y. Now what is the derivative of log of y? X. 1 upon x. So what is the derivative of log of y? Which is 1 upon y. And again a derivative of y with respect to x, which is 1 upon y dy by dx. Now again simplify. We can use here rules of differentiation, u minus v form. So क्या होगा? e raised to x minus y, derivative of x which is 1, derivative of y dy by dx minus dy by dx is equal to 1 upon x minus 1 upon y dy by dx. Now your aim is collect dy by dx term together. So this e raised to x minus y goes that side, multiply inside the bracket. So e raised to x minus y minus e raised to x minus y dy by dx is equal to 1 upon x minus 1 upon y dy by dx. Now collect the term dy by dx together. So this here minus goes that side is plus, this here plus goes that side is minus. So 1 upon y dy by dx minus e raised to minus e raised to x minus y dy by dx is equal to 1 upon x minus e raised to x minus y. Now dy by dx separate. 1 upon y minus e raised to x minus y multiply dy by dx is equal to this x denominator is not same, this x multiply here, 1 minus e raised to x minus y divided by x. Now same here y is denominator is not same, multiply here. So 1 minus y e raised to x minus y divided by y dy by dx. Now I want only single dy by dx, so whole term goes that side. So whatever here divided, RHS is multiply, and whatever is multiplied, RHS is divide. So क्या होगा यहाँ पे? So your final answer dy by dx is equal to 1 minus e raised to x minus y multiply x divided by x multiply y divided by 1 minus y e raised to x minus 1. So this is your final answer. I hope you understand which type of implicit function and how to derivative. So next lecture we start same implicit function derivative but prove that example. Thank you very much.